see. Okay, so here's the address of today's paste-in file, 3605495. Now, you don't need to be connected to the VPN for this, but I'd like you to be. So if you can connect your virtual machine to the VPN, it makes the lab a little nicer. Do you need to be connected to the VPN? No, you can run this stuff against your home network. You can run this stuff against, your own virtual machine. It's not a big deal. But let's get in here and let's just dive right in. Well, Tuesday, we played around with, excuse me. Gosh, I'm sorry, that's rude. I apologize for yawning. Okay, Tuesday, we played around with some log parsing. And log parsing is as fun can be, right? Can't think of anything more exciting than messing with some logs. Now, today, we actually want to start with port scanning. And there's going to be a couple of ways that you can deal with port scanning whenever you have to, scan a network. There's two real ways to do it. The first way is going to be sockets, and the second one is going to be to use something called scapy. So let's get in here and let's just dive right in that. Okay, yeah, Mike, you should have lab credentials, and if you don't, at our next break, I'll give them to you. Okay, so let's just dive right in. So we want to make sure that we're in the scapy scanners folder. I'm going to copy that. I'll zoom in and let you get a look at it. Scapy scanners. And you'll see that that's the folder that I'm in. Okay, so now that we're in this folder, I'm just going to do a real simple open up netcat. Now you're going to see that I'm going to have two command prompts actually open. I just opened a duplicate session. So in PuTTY, you can just right-click and choose the option duplicate session, and then you log into that. So I'm going to be working in this duplicate session, so I'm going to need both windows. So what it wants me to do is it wants me to use incat and start a listener. So I'm going to start a listener, incat, listen, verbose, just more output, on port 1234. So there, I'm listening on this port. Now, in my other window, I'm actually just going to start Python. So it just says type Python. And when you type Python, you see how Python starts and you get those three arrows. That's why I'm showing you right here that you type Python, and then you're going to get your additional arrows. Okay, so this stuff seems pretty easy. Let me move this. There we go. Okay, so this looks pretty easy. It just wants me to import socket. So socket is what's called a module. It's the module that allows you to interact with IP addresses and ports. So you're going to notice that a lot of hacker code out on the web has this first line, import socket. Now, whenever we want to work with a socket, we usually say S equals, and then we have all this gobbledygook right here. So what you're saying is S equals socket.socket, socket.af underscore inet. So what that means is you're instantiating the socket object. AF is address family, inet for internet, and then the socket type is going to be a stream socket, right? So bidirectional communication. So we hit enter. There we go. Now, you can remember that's how you instantiate a socket object, or you can remember whenever I need to talk to an IP and port, I need that line. Now, the reason that we want to have that line is just so it makes it so much easier for us to, from now on, just use S. Because I don't want to write all that crap out, right? So now I'm just going to do s.connect to localhost on port 1234. Now remember, 1234 is what I'm listening on up here. So now the connect method becomes available. So s.connect, I'm connecting to localhost, port 1234, and I'm going to send some data. Okay, the ultimate, most boring thing in the world we can possibly do, send hello world. So you'll see the connection, you see how we connected, you'll see our source port, 41441, obviously your source port will be different, and then you see that the hello world got sent, and now you're going to see me do this data equals s.receive, and I'm just catching 1024 bytes of data. And you see how this 12 came back? That was some of the data that came back. So I actually didn't catch it, but it's okay. So now I'm just going to close this socket. So I'll close the socket. So I close the socket, and then down here, I'm going to say print receive data. So I print receive data. Now nothing's happening. But over here, I'm just going to hit enter, and then you finally see it closed, and then the receive data thing actually print because the socket was finally closed. Okay, so the biggest thing here, yes, Joe, you are right. You can differentiate between AF INET 6 and AF INET 4. You are correct. That would be in here, trying to differentiate between IPv4 and IPv6. We're not going to be doing any IPv6 stuff in this class, but you are correct. If you wanted to do that, that'd be how you do it. Okay, so the question is the difference between s.send and s.connect. S.connect establishes your three-way handshake, and then s.send actually sends the data. Now, you can see some people kind of use them interchangeably. I've seen some code that does that. But I mean, at the end of the day, you know, you do need to be able to send your data, and it will work. So the S means socket.socket, blah, blah, blah. Yes, you are correct. S is the variable, correct. Okay. All right, so you're starting to see that this lets us interact with stuff. So if you wanted to connect to a port, then you could say, hey, let me connect to port 21, the Tcp Server port, and then if the port is open, right, because if I receive data back and the data back comes back and lets me know the port's open, I could print, hey, port is open. if I get something back like a reset ACK packet, I'd know that the port is closed. And then I could say port is closed, print port is closed. If I got no response, that would mean that a firewall or filtering device dropped the packet, so then you print port is filtered. So now that you know those three things, right, if I send a SYN packet and the port is open, I'll get a SYN ACK. If I send a SYN packet and the port is closed, I'll get a reset ACK. If I send a SYN packet and the port is filtered, you'll get dropped, you get no response. Okay? So it becomes a way that our port scanners work. So are you guys starting to see that it's a for loop with a nested if-then statement? So if you really stop and think about Nmap, as complex and powerful as Nmap is, all you're doing is creating a loop, and you're going to connect to any IP and port, and for every port in this list, connect to the port and see if it's open, closed, or filtered. This kind of makes sense how you're starting to think about it, guys? Okay, it just becomes the way you kind of look at it. So even though the code seems to be doing some pretty complex stuff, you're still using the same constructs that we use in all programming, right? Your for statement, your for loop, and your if-then construct. So now that you know this, you may not write a very efficient port scanner, but you can certainly write one. I mean, that's really all it is. You're just going to take what I just showed you, and then you're going to nest it inside of a for loop. And then the for loop is just going to iterate through all the ports that you want to connect to and see if those ports are open. That's really it. Now, the data that comes back, like if you want to see the banner, you could just write an if-then statement on the banner. So if the banner comes back as IIS 7.5, then print not vulnerable. If it comes back as IIS 5.0, print vulnerable. So now that you know that, that's how a vulnerability scanner actually works. So the difference between a port scanner and a vulnerability scanner, the port scanner sees if the port is open, closed, or filtered. It may do some other stuff, but that's the gist of it. The vulnerability scanner is going to query the port, see the banner that's running on the port, and then let me know if the port, if that service is vulnerable. So what do I mean by that? So let's say, for example, if I ncat localhost port 22, you guys see what comes up? SSH open SSH 5.9 T1. That's the banner. So when you connect to a server, that's the banner that you get. Let's say I ncat C1. Okay, so now let's say I take this IP address. This is my web server. So now if I ncat my web server, port 80, and now when you connect to a web server, you have to issue commands that the web server understands. And now right here, we can see what version of Apache that I'm running, right? So what you would be doing with your vulnerability scanner is you would do a for loop. So for every port that you connect to, read this banner. If in this banner you see Apache whatever, print vulnerable, else print not vulnerable, and then go on to the next port. Does kind of make sense, guys? Kind of hoping that you're following me here, because that's supposed to be like, ooh, ah, right? So I think the biggest thing, when I finally got a job working at a vendor where we made a vulnerability scanner, it really surprised me to see how simple these products really are. To be honest, vulnerability scanners are actually pretty dumb. I joined a project a few years ago called Wapiti. So joining the Wapiti project was a really good project for me because it was an open source web application vulnerability scanner, and of course it was written in Python. So this was the opportunity for me to learn Python because at the time I didn't know the language. I was pretty comfortable with web app stuff, but I knew, literally next to nothing of Python. So I joined the project and I started contributing some signatures and started kind of helping out. What really kind of shocked me with what you guys are going to learn in our next class is how to do web app testing, because it's the same concept. Now that I've taught you how to connect to a socket, it's no different from me teaching you how to connect to a web page. And then when you connect to a web page or a website, you send a specific type of data. Maybe it's a single quote. And then you read the response and look for ODBC or JDBC error messages. So if I see this error message, it must be vulnerable to SQL injection. Right? I mean, that's literally it. So you literally loop through every page of the website. Are you guys starting to see this logic? Right? Once you get this logic, again, I'm not saying that the tools that you write will be super, super efficient. There's probably better ways to do it. I'm not saying that. However, you can write tools. You really can. Don't beat yourself up that you're not the programming ninja. You can write tools. You really can. All right, so let's get down in here. Let's do our next thing. All right, so now that you've done that connection with Netcat, what I'd like for you to do is I'd like for you to build a simple TCP client. So we'll make a real simple TCP client. Okay, so let's look at the code of that TCP client. All right, so import socket, that looks familiar. All right, and then you see what we're going to say is socket equals socket.socket, blah, 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 and we make that equal S again. All right, that's awesome. Now we say host and port. So we have the host, which is the source IP, the destination IP address. This is where the traffic's going to go. Then we've got the port that the traffic's going to go to. Sounds pretty easy. Now you see how we can say s.connect, host port, and it'll go there. Okay? Now s.send, what do we want to send? We want to send a hello message. Then buff, s.receive, we're going to just open it up to catch 1024 bytes. Okay? When we actually get buff, we're just going to print back receive buff. All right, well, that's not too bad. I think we can handle that. All right, so then next, let's check out our TCP server. So we'll make ourselves a TCP server. Same thing, when you actually look at the server code, you're going to say to yourself, wow, that's pretty interesting. And it's interestingly simple. So look how similar this code is, right? Look, import socket, same thing, right? S socket.socket, socket address family, cool. All right, this time host port. All right, I don't need to specify the IP because it's listening. Okay. Now here we're going to listen on port 1337. Now look here, s.bind. So what you're doing is you're saying, okay, I need you guys to realize that you can run any web server or any server on any port, right? You know, your web server typically runs on port 80. But if you wanted to, you could change the port. Hey, I want to run my web server on port 81. Well, once you realize that when people use the term bind shell, that's because they're binding the NSH or cmd.exe to a port. So we call it a bind shell. So when you bind an application to a port, you attach the application to a logical port so that it can be reached over the network. So you can attach any application to a logical port. So when you think about it, your web server is just an EXE attached to port 80. Your mail server is just an EXE attached to port 20, port 25 or 110. Your FTP server is just an EXE attached to port 21. Okay? Now here you see that we're going to say, all right, I want to start this bind, and I want to listen. And now this is a trick that people do. They say, while one. Now what that means is, while one just means forever. It's just a ghetto way of saying whatever, because one exists. So while one, CLI address s.accept, print connection from, and then buff equals CLI receive, print receive buff. If buff equals hello, CLI send server ID 1. Okay, so CLI is just going to be our client, is address, s.accept, print connection from, and you'll see that it came from yourself. Now here, this is just allowing us to receive that much data. Now here's a little trick that we're doing. Guys, there's a difference between a single equal sign and a double equal sign. A double equal sign is a test. So now we're going to receive buff on that port. If the content of buff is hello, you're going to send server ID 1 to the stream. Okay? So, whoops. Let me right click and save that. So now let me Python Tcp Server. Okay, so I'm running that. I'll see you later, Tiff. Now I'm going to go Python TCP client. Okay, and this is just sending hello, right? So I send a hello, and you see right here it sends me back received 1. Okay, I just hit Control-C to kill that. Okay, so the return ports just increment by 1 for each connection. Is this true? Yes. Are you talking source port, Joe? Source ports? Oh, okay. Yeah, that's the source port. Yeah, that's the source port. Okay. So what happens is when you connect to a host, let's say you connect to a host on port 80, that's going to be the destination port. Your source port is going to be your local IP address with a port that's random anywhere from 1024 all the way up to 65,535. And it's the combination of the source IP, source port, destination IP, destination port that actually makes up what we call a socket. So when we're saying a socket, an actual socket is source port, destination port, source IP, source IP, destination IP. Source IP, source port, destination IP, destination port. That makes up a socket. Certain apps use specific blocks, or is it always random? Almost everything is going to have a random source port. Destination ports are usually defined by the application itself. Now, there are rare cases where people do what's called source port scanning, because port 20, for example, is the control port for FTP. So oftentimes you will see some Cisco devices have something called fix-up, so that they can handle whether the server is doing passive FTP or regular FTP where it's got a control port, port 20, and it handles the traffic that's coming back from these non-standard ports. So we don't really need to beat ourselves over that, because the IP stack is going to take care of that for us. We generally only need to worry about the destination port. For the most part, that's what we need to worry about. There will be some testing where you're going to send traffic with a source port of 53 and a source port of 20, trying to test the filtering device. But again, most modern filtering devices, this is a worthless test if the device is fairly new. Fairly new meaning like made within the last 10 years. Okay. All right, so you see that we can send a TCP packet. That wasn't too hard. Let's see if we can send a UDP packet. Okay, so just going to crank open UDP, so UDP client. There we go. All right, UDP client, surprisingly simple, right? If you look at that, everything is the same, except it's not sock_stream, it's sock_dgram. It's the only difference. So we've just done our client. Now let's go ahead and let's go for our server. So it's vi udp server.py. Okay, and now you're seeing the same thing, right? Surprisingly simple. I mean, just so simple. It's just that one change, right? It goes from stream to dgram. Otherwise, you guys notice it's all pretty much the same. And we're looking to see if the hello gets sent. So I'm just going to save that. I'm going to run the UDP server, so the server's listening. And now right here, let's run the UDP client. And now you see how the hello got sent. And the server ID of 1. Okay, so curious if you guys have heard of something called the SPSE from SecurityTube. So this is the Python for pen testers and hackers course. This lab that I just did with the TCP client and UDP client, that's exactly where they came from. Super, super, super good course. I love what the VEC is doing with the course. It's much, much more thorough than what I'm teaching. But I think we have kind of different goals. You know, my goal is just to get a person kind of get their feet wet and get them to where they feel like they can do something with Python. Where I think the VEC is really kind of trying to develop a person who wants to be a security expert using Python. So it goes over stuff that's really, really intense. I mean, the material starts slow, don't get me wrong, and it's very methodical, but it's the most thorough stuff on the market. So if you're looking to kind of take your Python and really get deep, you know, I think that's really where you want to go. The VEX SPSE course, I think for the money, I'm pretty sure that course is like $300. You know, so for the money, I don't think you can get anything more comprehensive. Definitely by far the best material I think I've ever seen on Python for security. Okay, the next thing I wanted us to look at was scapy. So I've got my good buddy, Sam Bone, and we're going to be doing a lab from his website. So that's what this next piece is. So it's really, really pretty handy. So let's just kind of take a look here. Now, in my case, we need to install scapy. I've already done it, so I don't need to do these commands, but you want to go ahead and do these commands. So you want to install scapy and then a couple of libraries associated with it so that scapy can do some really interesting things if you want to take it a little further. Scapy can do like network visualization, so you can visualize traffic and plot it and all this other really off-the-chart stuff. Okay, so let's get in here and let's get rolling with some scapy. All right, so the first thing with scapy, just go ahead and say sudo scapy. Now you're going to notice that it takes you to a prompt that looks, if I could do my password, it'll take you to a prompt that looks like the Python prompt. You kind of look at that and you go, huh, that's pretty strange, right? But if you look at Felipe Biondi's whole concept, let's see, I think it was a CanSec. Yeah, CanSec West Scapy. Felipe Biondi is a genius. I mean, it was the most amazing thing. I know when I first saw this presentation, this was several years ago that he did this, but I know when I first saw it, I immediately thought to myself, I'm doing something wrong. Let me walk you through a couple of things. So he says, let's look at some of the problems with packet crafting tools, rather. So you'll see that he covers the basics of Python because scapy is overlaid on Python. That's the first strength. Whoops, I'm sorry. Okay, so he said, all right, let's look at what's going on with packets. So he says the first thing you have is you have packet forging tools, packet tools that make packets and send them. Then you've got snipping tools, tools that capture packets and possibly dissect them. Then you've got testing tools, tools that do unitary tests and they try to answer some sort of yes or no question, kind of like a ping. Oh, you want the link to the PDF? Not a problem. It is right here. So you'll see that he says, okay, you've got testing tools, you've got scanning tools, you've got fingerprinting tools, and you've got attacking tools. So he says, just stop and think about this whole metric crap load of tools that we use to do all these different types of things, right? So for example, Etherreal is now called Wireshark, but TCP dump, net2cap, CDP sniffer, AIM sniffer, vomit, and then all these packet forging tools. And then you've got these testing tools, things like ping, hping2, hping3, traceroute, TCP trace, TCP traceroute, scanning tools like nmap, amap, vmap, fingerprinting tools, attack tools like DNS spoof, iprobe, ettercat, this whole laundry list of tools. And each of these different tools has a slightly different purpose. So watch this and see if this gets you the same way it got me. He says, most tools can't do exactly what you want. He says, for example, building a single working packet from scratch takes about 60 lines in C. The same with a command line tool is near unbearable. He says, popular tools use templates to fill in and get a working set of packets. And here's the big piece. You'll never be able to do something that the tool author did not imagine. He says, can you find a tool that can do an ICMP echo request with some GIT and packet data, do an IP protocol scan with the more fragments flag set, do ARP cache poisoning with a VLAN hopping attack, do a trace route with an applicative payload like DNS or ISOCMP? And, the simple truth is there's absolutely nothing on the market like this. Flat out nothing. He says most tools interpret the packets that they receive. So you're looking at what the programmer expected to receive, and then unexpected things go unnoticed. So here, he's using hping to send an ICMP packet, and as you look at it, he says, okay, here's the hex dump of the ICMP packet. You can see the 192.168.8.1, and you can see the hex of it down at the bottom, the C0A8 and the 0801. That's the IP address and hex. And you can see the time to live. Then you can see the ID. Here you can see the ICMP sequence number. Now I want you guys to look and see if you notice this. So he says, did you see? Now think about that. If you look at the whole rest of the packet, what's all this stuff? So he says some data linked into the padding, right? He calls this ether leaking. I had never even heard of this. I know when I first saw this, I was like, huh? It just blew me away. I remember looking at this and being like, you got to be kidding me. He says, interpretation is sometimes inefficient, right? Let's say you see a port that says it's filtered. Well, do you really know what happened? Did you get a no answer? Did you get an ICMP host unreachable? And if you did, from who? Was it an ICMP port administratively prohibited? And if you did get that, from who? Did you get it from the screening router? Did you get it from the firewall? What exactly did you get? Because is your no response, remember, port open, send packet, send ACK if the port is open. Port closed, reset ACK if the port is closed. If the port is filtered, you're generally looking for no response. But what if you got an administratively prohibited or ICMP host unreachable? Those might be considered by your tool to report it as filtered. So he says popular tools bias our perception of network systems. He says you've got a few really popular tools, but these tools give you a subjective vision of the system that are being tested. The world is seen through these tools, and you won't notice what these tools can't see. Bugs, flaws, they can remain unnoticed on very well-tested systems because they're always seen through the same tools with the same bias. This guy is freaking brilliant. Brilliant. So you see he says, okay, let's say you want to do something like scan a whole class C with a TCP SYN on port 80 and a given TTL. You need to know which IP addresses did not answer IC and key with the time exceeded in transit. The only available solution at the time was to have HPing SYN packets one by one with a control Z to increment for each host, and then use TCP dump to sniff to see if this was what was coming back. So look at how he thought about the problem. He says he needed a way to describe a set of packets of any kind and be able to choose any value of any bit in the packet. He needed a way to build them. He needed a way to send them, a way to receive answers, a way to match the results and the replies, and a way to interpret and represent the result. So this is what he came up with. This packet manipulation, assembly, routing, disassembly, receive, match, manipulation, visualization concept. This is kind of the overarching architecture of what scapy does. So he says the Python interpreter is disguised as a domain-specific language, right? This is brilliant. This is brilliant. He says fast packet design, default values that work, unlimited combinations, probe once, interpret many. Interactive packet manipulation. So literally, you can list layers of a packet. So when you open up Scapy and you do an ls with the parent signs, you'll see that all the different layers are DHCP, DNS, .11 for 802.11, and it just goes on and on and on and on. And then if you want to list the commands, you say LSC, and in parentheses, and then you'll see the SR, send and receive packets at layer 3. Then SR1, send and receive packets at layer 3 and return only, whatever that is. Then SRP, send and receive packets at layer 2. And it just goes on and on and on and on of all these ways that you can build and manipulate packets. So he says fast packet designing. Each packet is built layer by layer. So for example, you build the Ethernet layer first, then the IP layer, then the TCP layer, right? So each layer can be stacked upon each other. Each layer or packet can be manipulated. Each field has a working set of default values, and each field can contain a value or set of values. So you see that he creates an A, and A equals IP, and then in parentheses, the destination is target.com, and he sets the ID flag to 42. Now you see he's got A, and then the method, TTL, so he sets the time to live. Then he says B, and you see that it's TCP, and he sets the destination port, and he makes a list for those. TCP 22, 23, 25, 80, and 443. And now look what he does. He says C equals A/B. So now you're going to send traffic to target.com with the ID flag of 42, with the TTL of 12, to port 22, 23, 25, 80, and 443. So he makes this analogy the same way that you order food will be the same way that you build packets. So you want Big Mac, fries, ketchup, mayo, and then you want up to 9 chicken wings and a Diet Coke. I have no idea why, if you're going to eat like that, you're going to wash it down with a Diet Coke. Makes no sense. Go hardcore, man. Get the full-blown Coke Classic. All right, so now he says, okay, how do I order a packet with Scapy? I want a broadcast MAC address. I want an IP payload to, let's say, ketchup.com and to mayo.com. I want a TTL value from 1 to 9, and I want a UDP payload as well. So here you see the Ether destination address is all F, so it goes to the broadcast. The IP destination goes to ketchup.com and mayo.com. The TTL ranges from 1 to 9, and there's UDP. Now you see that he says we have 18 packets defined in one line, one explicit packet. So we've just never been able to build stuff like this before, not on the fly. And that's the real power of scapy, right? You're going to have default values that work, but if you want to change any value in any portion of the packet, you can. And I mean anything. I'm not kidding. Anything in the packet you can change. It's going to come with default values, don't get me wrong, but you can change it, manipulate it, do whatever you absolutely want with it. All right? He calls it unlimited combinations. You know, think about being able to do things like an ARP cache poisoning attack and a VLAN hopping attack, all in one implicit packet. You know, you can poison the cache, double VLAN encapsulation. You can do VoIP decoding with 802.11. You can also mess with WEP. You can deal with ISAKIMP. You know, you can trace route into VPN concentrators by sending applicative payloads. I mean, you can completely manipulate packets in any way that you want. You're only limited to what you can come up with. And this is what I think is just flat out brilliant, 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 brilliant. Okay, so off my sales pitch soapbox, let's play with scapy. So when you start with scapy, let's just set I to IP. So I'll just say I equals IP. Okay. Now that we've done this, let's display it. So now the display method becomes available. So we're going to say I.display, and then this implicit packet is built now. So you can see it's IP version 4. Nothing is really set in it right now other than the ID flag and the TTL. Source and destination are 127.0.0.1, and now we can start changing all of this stuff. So I'm connected to the network. You might want to change this IP address if you're not. So you're going to see that I'm going to say I.dst, see for right here. I'm going to set that to equal this IP address, which is a host in the network. Now, if I want to display it, you can now see that it's changed. Now I'm going to do IC, whoops. Okay, now let's set this up so I can handle the ICMP layers. So I'm going to call this IC, well, that's what's going to equal ICMP. Now, if I want to display that, here you can see that I just did an IC.display, and you can see that it's an echo request. And now, anyone who's had to take their CEH or any of those type of exams remembers that they really beat you up with ICMP type codes. You see that you could set that, huh? So you could set IC.code to whatever number you wanted, right? And you could set the sequence number to whatever you wanted. You could, you know, change any of this stuff. Now, what we're going to do is we're going to send these packets. So this is that SR1. So I'm going to send receive I. So I was this portion. That's why it's going to 30.61. And then the IC, that's this stuff. So you're going to send receive to this host, and then it's going to be ICMP. So I hit enter, and you see that the whole packet was sent. Okay? So got the answer, and now you can see here IP version 4. This is the time of service. Here's your ID flag, and now you can see protocol is ICMP. This was the source. This is the destination. Okay, so the source and destination, the ICMP echo and ICMP reply, work beautifully. Now, what we can do is we can do the exact same thing, and now inside of it, we can send that same ICMP packet, and inside of that padding data of the packet, we can send in the payload whatever we want. Now, you can do the same thing over UDP. So I'm going to just set up a quick UDP listener. So I'm listening on TCP port, on UDP port 4444. And now what I'm going to do is I'm just going to up arrow and I'm going to change. I'm going to change this to my IP address of this host, 2.97. Okay, and let's set up the UDP portion. So U is going to be UDP. And now if I want to display it, just U.display. Now we can see source port's domain, destination port is domain. Domain meaning domain name service, so too shabby there. So now I'm going to set the destination port to be 4444. And then we can display it. So now you can see that it's going to the destination port, 4444. And now the same way that we sent this packet before, okay, all right, so now I'm going to send that scapy for the win, sent via UDP. I'll check over here. Yep, got it. Got it. Okay, so now we have a way that we can send and receive packets. Now, raw socket stuff with the socket library, pretty handy. Pretty handy. You just need to connect to a port, see if a port is open. You know, hey, you're cooking with Crisco, right? Now, if you want to do some really interesting packet type stuff, you know, different packet, different protocols, you know, all that kind of stuff, you're probably going to want to do it with something like scapy. Now, scapy is designed to be used in tools. Like, they specifically made it, Felipe specifically wrote it so that it can be something that you use to help you create tools, right? Amazing, amazing, amazing. So you're going to start, you're not going to start. You will see a lot of tools out there that use scapy. Metasploit actually came up with Scrooby, which was a way to implement scapy-like functionality rewritten in Ruby. So they needed to do that because obviously Metasploit's written in Ruby. So you're going to find that this type of functionality is changing the way that packet crafting is done. So let's take a look at what some scapy-based tools would look like. Okay, so real quick, what I'm going to do is I'm going to quit, and I'm going to create ping suite.py. And now let's grab this. Okay, now just because I'm lazy, let's change this. Hit I. Let's get in here. Let's change this to 105. And let's change this to 50. Yeah. Okay. All right. So you're going to see that you're going to run Python, and because scapy is installed, you can just say from scapy.all import everything. So now, boom, you've got scapy. Okay, so you've got this timeout equals 0. You've got this verb equals 0. You don't really need to worry about that, but this is one of those kind of scapy isms, but I'll get to that a little bit later. So now let's look at this for loop. For IP in range, and you saw that I just changed my range to 50 to 105. Packet equals IP, and now here, destination is going to be 10.10.30, and then we're going to take this as a string. So this number right here is going to be placed right here. You can see that we've got the TTL of 20, and we're going to turn this into an ICMP. So now, reply SR1, packet equals timeout. Now you notice what's nice is we can change the timeout, right? So now, if not reply, print reply from this destination is online. So what this is going to do is you see right here, reply, because you did reply.dst, that IP address is going to show up, and then there's a space, and it's going to say is online. Okay, else print timeout is waiting for, and then here's the string, and this is going to be this packet, and it's going to be this IP.dst. So it's going to show you, hey, I'm waiting for this guy, waiting for this guy, waiting for this guy. Let's right click. Okay, so let's Python ping sweep. Let's throw the sudo in front of it just in case it needs raw socket access, right? Okay, so we'll run that bad boy, and let's, okay, guess I just cannot type my password these days. Okay. Yay, we got some boxes online. Okay, didn't hear from .60. 203 is online. Okay, haven't heard from .71 yet. Still waiting on 72. Waiting on 73. Waiting on 74. Waiting on 75. Okay, not too shabby. Not too shabby. Ping sweep is working, huh? All right, I'm not going to hang out through all that. We saw a couple of those hosts were online, and when it gets into the 60s, it'll find some hosts online in there too. But we're already at 8 o'clock, so we don't need to wait for all of that. Okay. All right, so I'm going to Control C. Okay. All right, so we got that all killed. Make sure you guys don't have any questions. All right, now I'd like for you to look in this directory. And in my case, I should already be in there. And you're going to see that we have a bunch of scapy scanners. So let me clean up the stuff I just wrote. Where's my RMRF command? I deleted all this stuff a little while ago. Okay, guess not. What's RMRF? Pcp star UDP star. And that should be it, right? Yeah. Okay, so what's left in the directory is RDP scan, SSH scan, what's left in the directory, RDP scan, SSH scan, VNC scan, Telnet scan. Let's look at the VNC scan script. Okay, so let's see what we got here. Let's open it in VI. Life is always better with color, right? There we go. All right, so okay. So now it says it's going to run user bin env Python. This is a good little thing for you guys to notice. You guys notice I always use user bin Python, but this has user bin env Python. What this does is it says, let me look at your environment variable, and let's run the version of Python that's relevant for you. Okay, this is good when people install multiple versions of Python. Okay, all right, so it says that it scans a range and prints out a list of targets that have the VNC port open. So let's see how it works. It imports sys. Now it says from scapy import everything, okay? Let me comment this. Okay, now it says if length of sysargv does not equal 2. All right, so if the length of sys.argv, that's argument vector, so what that means is argv1 is going to be the program name. argv2 is going to be the next argument that you specify. So now you're going to say, okay, so print. So right here, if this doesn't work, if you specify too many parameters and not enough arguments, it's going to print this message. Here's how you use it. And then it's going to say where target is arranged like this. Okay, I can handle that. So now here you see that they define target. Target equals sys.argv1. All right, cool. I can handle that. Okay, so now it says P equals IP destination equals target. Okay, nice, so that'll be what we specify. Great. TCP destination port 5900, that's the VNC port. The flag that we're sending is the S, so that's a SYN flag, SYN packet. Okay, and now here you've got answer, and then this just specifies the timeout. Okay, not too bad. And now we're going to say for A in answer, if A.1 flags equals 2, print that IP address. That's it. So basically, if it responds, print it. Okay, cool. So let's run this bad boy. Okay, now sometimes when you need raw socket access, it's a little bit easier to just run it with sudo. So I'm going to say Python sudo VNC scan, conf.verb equals 0. Name error, conf is not defined. Okay, so the best thing to do when you have an issue is Google it. So I would say to Google that error, because that's exactly what I did when I got stuck with this problem. And you'll see that someone ran into the same problem. Okay? All right, so it says, hey, it's because they've updated scapy. So what you need to do is you should say from scapy.all import everything. And if you look at our script says from scapy import everything. I already have this in your notes. So in your notes, it says how do you deal with that error, and then it gives you what you need to change it to. See? So from scapy import to scapy.all. And then it gives you the reference, same page that I'm at. So we can change that. So scapy.all, there you go. Now if you want to run it, it runs. Okay, so now let's say you throw in 10.10.10.0/24. Now it'll get out there and it'll run. Okay. So we don't really want to sit there and let this whole thing run forever, but there's a couple of machines in the 10.10.10 network that are running VNC. So that's why I put the network to scan for that, but we'll be scanning here for days, so I'm just going to stop it. Okay. All right, so now if we just look, let's check out the SSH scan script. So if I check out the SSH scan script, what are you guys noticing? Come on, guys. What are you noticing? Really complicated script, right? Same scapy issue. So you just need to change that to scapy.all. Okay, what else? Really complex script here. How is this different from the VNC script? How is this different from the VNC script, guys? Drastically different script, right? Right, and you'll see there's the change. Previously, we were looking for port 5900. This time, because it's an SSH script, we're scanning for port 22. Other than that, the entire thing is the same. The entire thing is the same. What if we check out the RDP script? It's like, yeah, I really overthought that one, huh? Yeah. Okay. What if we look at the RDP script? What are you guys noticing? Yes, that's it. I mean, that's really all this is. That's really all this is. So now that you're starting to see it, guys, we're back to our same programming constructs, right? Okay, guys, who remembers? A program can only do three things, right? What's the first thing a program can do? Come on, guys. First thing a program can do. Three things. There you go, processing, good. Give me some examples of processing. Read, write, math, beautiful. So processing, an example of processing is read, write, math. Okay, next thing, what's the next thing that a program can do? Program can process, a program can do what? Decisions, good. So a decision would be like an if-then. Excellent. Okay, what's the last thing that a program can do? The last thing that a program can do is loop, and that would be like your for loop or your while loop. So once you have this, you start to see that you come up with these really simple constructs of saying, okay, I just want to connect to a port and see if it's open. And now if I'm going to do a port scan, I'm going to read all the ports into a list, and for every port in the list, to it and see if it's open. If I want a banner grab, do like a vulnerability scan, for every port in the list, I'm going to connect to it, read the banner, and then decision. If the banner is X, then I'm going to print vulnerable. Else, if the banner is Y, print not vulnerable. Okay? So as you guys are starting to work through this, you know, being able to program, you don't need to be the ninja for this stuff. You really don't. You really don't. Don't beat yourself over the head like, oh my God, all these guys who write all this code, geez, they're just so amazing. You know, this is not the case, man. It's not the case. It's time. Truthfully, it's just time. Most of these people are so good at writing code because they don't do anything else. You know, they don't do things like date. You know, they don't do anything else. You know, so if all you did was sit around and write code, yeah, your code will look pretty doggone good. Okay? So let's stop right there, guys. Let's take a quick bio break. And then we'll handle some questions. Yeah, you're right, man. I need to work out. I am in like straight fat boy mode. Ugh. Watch. I was doing this thing for Facebook the other day, right? So I was looking for pictures, right? And what was the one that I found that I was just like, oh my God, I'm fat. That one. I was like, God, oh my God, I'm huge. What happened to insanity? Oh, God. Oh, you're going to make me feel so guilty. Okay, I did insanity for about 3 weeks. I think I lost about 11 pounds. And then after that, I, like, ballooned. I think I gained back, like, all the pounds and then, like, you know, a whole lot more. I'm going to do it again. I'm going to do it again. I'm just working on building the motivation to do it again. The plan is to do it again in January, and I want to do the whole 60 days this time. So, again, it was working. I cleaned up my diet. I was doing it, but, man, see, Joe, I'm with you, man. The problem is food is delicious. And Joe loves some food, man. Just loves some food. God, dog. I'm going to try that. The plan, I cut starches. I cut starches last time. That's what made me lose the weight. The plan is to cut the starch and this time cut my sugar. But we'll see. We'll see. Are you guys going to give me moral support? No rum. Oh, my God. Hack the body. Okay, guys. All right, let's see. I think we covered a lot today. I really think we covered a lot. Definite shout out to my buddy Vivek over at SecurityTube. If you're really trying to learn Python, I really think you should look at his SPSE. Sam's class, I think what Sam is doing for college is just flat out amazing. I really think he needs to do more of this kind of stuff because this is what our education system really, really needs. So shout out to my buddy Sam. Good job. His courseware is samsclass.info. So I'm thinking that'll be some stuff that really helps you. I'd like for you guys to write your own port scanner now. So that'll be a nice little challenge to give yourself. So, you know, you can Google write a port scanner. It's scapy. Okay? And there's going to be tons and tons and tons of good resources out there for how to write port scanners in scapy. I have been getting your homework, yes. I haven't gone through it because I'm just almost caught up with emails right now. I got to get certificates for last week's class out. I got to get pathways for people, and I got to review homework. So, yes, I've been seeing those stuff come in. I just got to get them done. But I've been working, and I worked. Okay, so definitely port scanning. I think this one was a really good one. Being able to do all these different port scan types. It was from InfoSec Institute's website. Really good blog on port scanning using scapy. I thought it was really good. Yeah, Joe, I don't have a date yet for that exploit dev class, but I'll probably do it in the next couple of weeks. The idea is to either do it not Thanksgiving weekend, but probably the weekend after it or the weekend before it, which would be next weekend. But I think I'm supposed to be doing like a capture the flag thing. Are any of you guys interested in doing a CTF? Okay, yeah, a couple people. All right, yeah. So, yeah. So the idea of the CTF will be for beginners and intermediates. I'm not going to make like the ninja CTF. We'll make something that actual humans can do. But yeah, if you guys are interested, I'm working on it right now. I'm going to get the documentation out about it, and it's going to be a for charge CTF, so you will have to pay to take part in it. But what I want to do is I'm going to make the rate discounted for previous students is the plan. So if you're a previous student, we'll cut you a super scary, awesome discount because you guys actually put up with me. And why, I don't know, but I love that you put up with me. And then anybody else, hey man, they can, hopefully become a student, and then I'll be nice to them too. Okay? All right, guys, I say let's button it up for the night. I think we did pretty good. We did pretty good. All right, any last questions before we wrap this sucker up? There's no pathways for this class, no. No problem, Tony. Okay, Scott, shoot me an email. I'll make sure I get your VPN stuff squared away. No problem. Michael, same thing. Are the slides available? Didn't I give the slides? Let's see. You guys need the slides for this class? Huh. Okay. Guys, did I send out the slides? Victor's saying that he wanted the slides. You guys remember the slides that I did last week? Did I send those out? Yeah, the Python for Security Pro slides. I didn't send them out. These ones. Okay. I will send those out as part of tonight's email. Yeah, I'll send these guys out, okay? No problemo. No problem. No problem. Okay, guys, your homework is to write your own port scanner. All right, guys, I'll get slides out and I'll get the video out in a little bit. All right, everybody, take care.